I'm Sam Schreiner from Sakari Farms. We are a tribal farm in Tumalo, Oregon, Central Oregon High Desert, and we grow for value-added food products and also for food donations to tribal entities like Warm Springs Reservation. We're really excited to be involved in this project because we feel like with the drought and having to deal with lack of water through an extremely hot summer, I think the data is very useful for a lot of people, and it certainly influenced our practices throughout the growing season as well. We are located just east of the Cascades. We're about 3,600 feet or so elevation. Sandy loam soil, super short growing season. It typically is about 56-ish days, somewhere around there. Due to our location, we basically grow everything in high tunnels. We have about 6,000 square feet right now under plastic, and that's the only way that we can successfully grow things in this climate. We're on Tumalo Irrigation District. We are fortunate in the fact that Tumalo Irrigation District has piped a good amount of their canals and laterals, and we don't have the evapotranspiration from canals and ponds. Our irrigation season would typically run from mid-April till October. This year it was mid-April, and today, September 23rd, is actually the last day that our water will run for the year. We do have an irrigation pond that is big enough to sustain us for a little while, but we do drain it within 2 weeks, I would say, when we're irrigating in the summer. We have been slowly converting from just standard hand lines and overhead to using more and more drip irrigation to save water. Our greenhouse space, so about 6,000 square feet, covered with drip tape, and another plot outside covered with drip tape. The rest of it, which is about 1.2 acres, is just overhead hand lines still, which we will be converting to drip in the future. We are primarily growing for value-added products. Most of our crops that we grow are full season. We do typically one bed prep in the spring and grow that crop all the way through the year. Our bed prep and tillage practices have been kind of evolving with everything else, but essentially we are using tractor or walk-behind tillers, spreading compost, and that is our bed prep regimen. We've been slowly converting some things to no-till. So for our 3 beds, we chose to do beets, golden beets for our crop. Our initial planting was transplanted, so we started those early spring in 72 cells, and then the gophers helped themselves to about half, which were then direct seeded after the fact. So we do have essentially 2 plantings of beets in there. So for our 3 beds, we did 3 different practices for preparation. Number 1, the control bed was standard tractor tillage and then compost topped, and that's basically the way that we do all of our beds in the field. So that's kind of our just control setup. The next 2 we started as no-till beds last season, so this would be their second season as no-till, and we did one as a hand-formed raised bed and the other one as a hand-formed depression. The no-till beds were hand-formed with shovels last season as raised beds. So the one that was a raised bed, basically all we did there was clean it up, rake it out, top it with compost. The depressed bed, we just dug the raised bed portion out to the side and just made a depression with hills on either side, and then spread the compost in there. So we noticed some differences right off the bat with the sensor readings. With the tilled bed, it was definitely the first one to start showing readings and drying out. I think it drained a lot better and didn't retain as much moisture. The depressed bed, on the other hand, was the one that stayed very evenly moist. When we got through the really hot parts of the summer, it did start to dry out. But overall, if you look at the graphs of it, the depressed bed has a much more, I guess, linear graph, and doesn't fluctuate nearly as much. So I think that as far as crops go, that was the best one. But that's not the whole picture, because it was actually also the weediest one, because we dug down and uprooted all of the historical weed stock in the soil and had a ton of weeds in that bed. And due to its depression and having 2 rows of plants down the middle, it made it so that we couldn't run a wheel hoe down it, and so we could only hand weed it, and it was suddenly not as practical. So our bed 2 is our no-till hand-formed raised bed, and we interplanted bachelor buttons with 2 rows of beets. So it was a row of bachelor buttons on the south side, and then 2 rows of beets after that. And what we noticed with that bed, and I'm pretty sure it's all because of the bachelor buttons, but that one dried out the most. Once the sensors came online and started giving us some good data, I think the bachelor buttons were vigorously pulling all the water away from the beets. However, that's the row that produced the most beets and the biggest beets. So I think that having the windbreak from the bachelor buttons may have kind of outweighed the fact that they were pulling all the water out of the bed. The data that we got from the sensors was really interesting this year. I feel like if we didn't go through having drought water cutoffs, we might not have taken away much other than just reading sensors every week. But we were actually measuring the sensors when our water was shut off, checking on the moisture, and determining our irrigation schedule based on that. I learned a lot about it based on how much water the root zone of the plants actually held. It was a lot better than I thought, and just instilled a lot of confidence in us over the summer, especially in the heat waves where it's over 100 degrees and we have no water in the pond and no irrigation for days. And it just made it so that we didn't have to worry, because we could look at the sensors and know that they're still reading really low. And so it was very beneficial, helping us in our practices for irrigation, and definitely in the future, just the knowledge of how the water retention works in that field, with the different crops and all that. I'm really excited to use the sensors in the future for a broader range of crops, maybe for monitoring inside of our high tunnels. But yeah, just the learning process of how they work, how they read, and the data that we can get from them is very powerful, especially growing here in this extreme high desert climate. So just having that extra set of data, the eyes below the ground basically, is super beneficial.